Hi everyone. Today we will learn one case study, which is the contest leaderboard, right? For example, in the lead code, whenever like online contest is happening, so there is one leaderboard, right? So, uh, so before we can start, let roughly estimate the traffic and the storage. Okay. So we will uh, do the case study of contest leaderboard contest leaderboard. So let's guess that we have 1 lakh participants in the contest. 1 lakh participant, and we can assume that there are 50 submission every seconds, around like contest wise, right? I'm not talking about the user wise, so I am assume that around every user doing 5 submission like during the contest, and so overall 50 submission there per second contest wise. 50 submission per seconds. And if we think that on an average one user uh, like watching the leaderboard 10 times like over the contest, then like per second like 100 views per second, right? So now we have to design a leaderboard which support 100 like views per second, right? And on an average 50 submission per second is there. So in my app server 50 submission request is coming, and at the same time, at the same second, 100 request coming for the fetching the leaderboard. All right, so now we have to support it. So like before we can start, how our leaderboard will look like, right? So in the leaderboard, ideally there is one rank, right? There is one rank, there is name of the user, total score, and individual problem score. For example, let's assume that in the contest we have 5 problem, right? P1, P2, P3, P4 and P5 score. Okay, so we have total score and individual score in the leaderboard, right? So like how and we have 1 lakh participants. So 1, 2, 3 up to 1 lakh, right? So there is 1 lakh participant, and the size of leaderboard, let's assume that one entry is size of 1 KB. So the total uh, like how much like leaderboard size will take. So it will, for example, 1 KB per entry. So we have how many entry in the leaderboard? There is 1 lakh entry, 10 to the 5,000, 10 to the 5 entries. So total 100 MB of leaderboard size, right? So in like we have to like leaderboard will look like this. Now in the backend, how leaderboard will calculate? So there are 3 to 4 table in the database. So first of all we have to uh, find the user from that contest. So we have to do the join of users with contest. Then we have to figure out how many problem in the contest. Like we have to figure out the a problem. We have to fetch the problem associated with the contest. So we have to do the join with contest and problem. And for the for the contest, for the every problem and from the every user, we have to like get the submission, right? So we have to do the join with users with submission. And so we have to fetch it from the database, then we have to calculate, and we have to sort it based on the score. So we have to like do this amount of processing in the backend. So let's assume that it will take around 1 minute of time, since there are 1 lakh entries, right? So let's assume that it will take around 1 minute of time to calculate the leaderboard. Right now, so do you think that like calculating the leaderboard on the every submission is feasible, since every second we have 50 submission requests and 100 view request, right? And the other thing here, the problem is the consistency, right? So uh, yeah, so I don't think we can support the uh, like uh, immediate consistency. And again, the uh, we can in the leaderboard we can display that leaderboard will refresh every 5 minutes, right? So in the leaderboard, is it okay to not provide the immediate consistency, right? So we can consider the eventual consistency, where so of 5 minutes, right? So every we can uh, show the banner at the top of the leaderboard, that leaderboard will update every 5 minutes, right? So in that way, we have to provide the eventual consistency. And since we are showing the like leaderboard every 5 minutes, so uh, I don't think we needs to calculate the leaderboard for the every request when user like watching that leaderboard, right? So I think so we have to cache it somewhere for the 5 minutes, right? So every 5 minutes we have to update that cache. So for the caching, we have to choose two things: what type of caching we have to use, and what type of policy we can use for the invalidation and the eviction, right? So first question is, what type of cache we can use. So there are two types of cache. One is local cache, and second is global. In the global as well, we have a single cache, and we have distributed cache. Since the size of the leaderboard is 100 MB, we can use the single cache, no need to use the distributed cache, right? So yeah, so that is confirmed, we can use the global cache as well as the global with single cache, right? Now, so like before before deep dive into the cache policies, let's draw the architecture, right? So we can get the better idea. So there are a user, right, who is watching the leaderboard, and the other is like submitting the problem. So there are one app server for like serving the leaderboard leaderboard. There is another server which serving. This is the app server. This is serving the submission REST API. Submission REST API. So user will submit their problem here in the submission API. So what this server will do, it will write into the one SQL database, correct? SQL database, alright. And and there is one cron job, I mean one app server, we can say cron job, which will run every 5 minutes. That cron job will run every 5 minutes and calculate the dashboard, correct? So so what app server will do is calculate the leaderboard every 5 minutes. What this app server will do, it will write into the cache. This is we can say it is the Redis and memcache. Redis, this is the global, and whenever whenever the request coming from the user for watching the leaderboard, it will directly fetch it from the Redis server, right? So this in that way, like how this is how it the architecture will look like. And here if you see, we have used the cache around policy for the invalidation, since uh, cache around. So let me explain the cache around. But if you wants to understand the cache around policy, then you can like go to my like video where I have explained the cache around policy in depth, right? So in in the top view, what cache around cache policies look like. So there is one cron job which will periodically updating the cache, so that is the cache around, right? So here we have a app server which will that is the cron job, and it for the every 5 minutes it is updating the Redis server, and updating the leaderboard in the Redis. So this the responsibility of this server is to just fetch the leaderboard from the Redis and serve it to the user. So there is not any big deal, right? It can like serve 100 views per second, and this the responsibility of this server is to just uh, like write the submission data into the SQL. So in that way we can achieve the 100 submission per second, and we can like support the 100 views per second. Yeah, so that's it about the like leaderboard like case study, right? So if you like think that my video is info like will help you, right, then please like my video and subscribe my channel. Thank you.